Way number 14 has to deal with heat flow. In order to evaluate which direction heat is flowing to and from, we need to look at the temperature of the substance. Heat flows from the hotter substances, the one with higher temperatures, to the colder substance, the lower temperature substance. So in order to evaluate the direction of heat flow, all we really have to do is look at the temperature values for the substances in question. Let's try some problems. In a laboratory where the air temperature is 22 degrees Celsius, a steel cylinder is at 100 degrees Celsius, is submerged in a sample of water at 40 degrees Celsius. In the system, heat flows from. So to do this problem, it sometimes is helpful to draw a picture of all the various objects and then write down the temperatures of the substances to evaluate the direction of heat flow. Remember, heat always flows from the hotter to the colder substances. So think about which substances are making contact with each other and which of the two is hot. Okay, we see that the steel cylinder, which is at 100 degrees, is submerged in water at 40 degrees. So the direction of heat flow will be from the cylinder to the water. Now, what is the water making contact with? The water is making contact with air at 22 degrees Celsius, and currently the water is hotter than air. So what's the direction of heat flow between the water and air? Water's heat is flowing from the water to the air. So the only one that fits all those criteria is answer choice 4. The cylinder to the water and from the water to the air. Cylinder is hotter than the water, and the water is hotter than the air. And the cylinder and air are not making contact with each other because the cylinder is submerged underwater. Let's try another problem. Object A at 40 degrees Celsius and object B at 80 degrees are placed in contact with each other. Which statement describes the heat flow between the objects? Okay, note that object B is hotter than object A, and since they're in contact with each other, we would expect the heat to flow from object B to object A. Therefore, answer choice 2 is the correct answer. If they were at the same temperature, we wouldn't expect any heat flowing between the two substances, so we can eliminate the other answer choices. Let's try another problem. A person with a body temperature of 37 degrees Celsius holds an ice cube with a temperature of 0 degrees Celsius in a room where the air temperature is 20 degrees Celsius. The direction of heat flow is. So again, for this problem, it sometimes is helpful to draw a picture and write down the temperatures of all the objects in question to determine which ones are making contact with which, and then use the temperature values to determine the direction of heat flow. Okay, because the person is holding the ice cube has a temperature of 37 degrees Celsius and the ice cube is at 0, we would expect the heat flow to be from the body of the person to the ice cube. But the ice cube is also making contact with the air at 20 degrees Celsius. So which one of the two is hotter? Well, it's the air at 20. Therefore, the direction of heat flow is from air to the ice. So currently, heat is flowing from the person to the ice cube and from the air to the ice cube. Therefore, the answer choice is 2. From the person to the ice and from the air to the ice. But please note that the temperature of the person is at 37 degrees Celsius and the air is at 20 degrees Celsius. So since the person is making contact with the air and the person is hotter, we would expect the heat flow to be from the person to the air as well as the ice and from the air to the ice, since those are currently the hottest objects in question. Base your answer to the question on the information below and on your knowledge of chemistry. Thermal energy is absorbed as chemical reactions occur during the process of baking muffins. The batter for muffins often contains baking soda, sodium bicarbonate, solid, which decomposes as the muffins are baked in an oven at 200 degrees Celsius. The balanced equation below represents this reaction, which releases carbon dioxide gas and causes the muffins to rise as they bake. The H2O liquid is released into the air of the oven as it becomes vapor. It gives you an equation. 2 sodium bicarbonate solid plus heat yields sodium carbonate solid plus H2O liquid plus CO2 gas. It says state the direction of heat flow between the air in the oven and the muffin batter when the muffin batter is first placed in the preheated oven at 200 degrees Celsius. So despite all this information about the problem, you really only need to look at the temperature values of the muffin batter and the preheated oven in order to determine the direction of heat flow. So look at the problem and think about which direction the heat is flowing from. When the muffin batter is first placed into the oven, we would expect it to be colder than the air of the oven, which is at 200 degrees Celsius. Because this cold muffin batter is making contact with the hot air, heat is flowing from the air to the muffin batter. So the answer is heat is flowing from the air to the muffin batter because the air is hotter than the muffin batter. Let's try another problem. Carbon dioxide, CO2, changes from the solid phase to a gas phase at 1 atmosphere of pressure and 194.5 Kelvin. In the solid phase, CO2 is often called dry ice. When dry ice sublimes just means convert from solid to gas, in air at 298 Kelvin, the water vapor in the air can condense, forming a fog of small water droplets. The fog is often used for special effects at concerts and in movie making. State the direction of heat flow between the dry ice and the water vapor in the air. So again, for this problem, all we really need to do is evaluate the temperatures of the substances in question and to determine the direction of heat flow. Okay, because the dry ice is colder than the water vapor it's making contact with, the water vapor is hotter than the dry ice, we would expect the heat flow to be from the water vapor to the dry ice. So again, when evaluating problems that involve heat flow, all we really need to look at is the temperature of the substances in question, figure out which ones are making contact. Sometimes it's best to draw a picture and write down the temperatures of all the substances in question so that you know which substance is the hotter substance. Remember, heat always flows from the hot to the cold substance, and you're going to use temperature values to evaluate the direction of heat flow. Thank you for watching.